The ABS sensor is also called the wheel speed sensor or anti-lock brake sensor. The ABS sensor usually consists of a toothed ring and a magnet enclosed within a coil. The contact between the ring and the magnet induces an electric field due to which a signal is generated. This signal is sent to the ABS controller. The toothed ring is also called a tone ring, and is attached to a part of the vehicle that is rotating at the same speed as the road wheel, such as the wheel hub, brake disc, CV joint or the drive shaft. Wheel speed sensors are installed directly above or next to the pulse wheel. Older configurations of ABS had the sensors located outside the wheel hub, in parts such as the steering knuckle and differential housing. The ABS sensors in newer systems are fitted in the wheel hub assembly itself. Depending on the integration of sensor functions in hub bearing units, the sensor can be either non-integrated, which is the case in the most simple application, or an integrated design. The integration of the sensor in the hub reduce assembly time, improve reliability, reduce space requirements, and reduce weight. Depending on how ABS sensors operate, they are classified into two different types: passive, analog, and active, digital. Passive is without a power supply and active is with a power supply. The passive sensor, also termed inductive sensor, operates without a supply voltage from the control unit, and generates its own voltage signal when vehicle is in motion. Passive sensor generally requires two wires, terminals on a wired sensor or two terminals on a sensor without a cable. Passive ABS sensor is an electromagnet in which a AC voltage is induced into the coil. It comprises of a coil surrounding a permanent magnet pickup core and an incremental encoder. Both are arranged so that there is a clear gap between them. The impulse wheel is a metallic ring, which rotates at the same speed as the wheel. The rotation of the reluctor ring increases and decreases the magnetic field between the notch and the tooth to generate a voltage in the coil. As the gap between the notch and the ring changes with the rotation of the reluctor, the sensor generates an analog sine wave voltage signal. The passive ABS sensor creates AC signal that changes frequency as the wheel changes speed. The ABS control unit converts the AC signal to a digital signal for interpretation. The shape of the output signal depends on several factors: sensor magnetic field strength, number of windings of the sensor's coil, shape of the rotating pulse wheel, gap between the sensor and pulse wheel, and speed of pulse wheel. Passive sensors are mostly used in older vehicles with ABS. They are larger and less accurate than active sensors, and only start to operate when the wheel reaches a certain speed, typically about 5 miles per hour. Systems such as stability control and traction systems cannot use passive types. Passive sensors are also unable to detect the rotation direction of the wheels. Impulse wheel design varies in type and size, but the operating principle is the same. An impulse wheel has either square teeth or rectangular openings. An impulse wheel is part of the bearing outer ring, produced by cold forming. A separate impulse wheel, that is pressed on the rotating component. An impulse wheel pressed onto the outer bearing ring. The impulse wheel is embedded between the tapered roller rows. In this design, the sensor is plugged into the outer ring with a very small air gap. The impulse wheel can be positioned on rotating components that are in close contact with the bearing. In this example, the impulse wheel is mounted on the CV joint. An angular passive sensor is located in the radial space, between the swaged shaft end and sensor cover. Active sensors require a supply voltage to operate, and work in conjunction with a toothed or magnetic ABS ring. The supply voltage is called a reference voltage. Active ABS sensor has an integrated circuit within the sensor that converts and amplifies the signal. The sensor can be a 2-wire or 3-wire system. Active sensors generally have 3 wires: power supply, signal return, and earth. But some active sensors have only 2 wires, reference voltage and signal return. Active sensors create a square wave, digital signal, which is transmitted to the control unit in the form of a current signal using pulse width modulation. Active sensors are a lot more accurate and are able to detect very slow speeds of less than 0.06 miles per hour. This is vital for modern traction control systems. Newer active sensors can also detect the direction of rotation. The impulse wheel for active ABS sensors are mainly multi-pole magnetized ring, affixed to the rotating part of the wheel bearing. Some active sensors are also used with a toothed wheel. The impulse wheel is magnetized and consists of alternating north and south poles. There are no teeth, only magnetized fields face the sensor. There are 2 types of active sensor: the Hall sensor, and the magnetoresistive sensor. The Hall sensor uses the Hall effect, which is a generation of a voltage, the Hall voltage, across an electrical conductor, transverse to an electric current in the conductor and a magnetic field perpendicular to the current. Current source is applied through a thin sheet of semiconductor material. A magnetic field applied perpendicular to the element creates a voltage change, V Hall. Active Hall effect sensor comprises a semiconductor coupled with an electronic circuit. It produces an alternating current. The electronic part of the sensor converts the analog signal of the current to a digital signal. Hall sensors record the wheel speed via either a toothed or magnetic encoder, ABS ring, often found on the wheel hub, disc, or bearing. In the case of using steel pulse wheel, a magnet is mounted on the Hall IC that generates a constant magnetic. With a magnetic encoder seal on the wheel bearing, the magnetic field is generated by the north and south poles of the magnetic encoder seal as they pass in front of the sensor. A magnetoresistive sensor has a sensing element that contains an output module and magnetic material. The magnetoresistive resistors integrated in the electronic circuit of the sensor detect an alternating magnetic field when the multipole ring rotates. This sinusoidal signal is converted by the electronics in the sensor into a digital signal. It is then transferred to the control unit as a current signal using the pulse width modulation method. In magnetoresistive sensor, the magnetic field applied parallel to the element, changes its resistance and creates a current change. The resistance increases or decreases depending on the orientation of the field lines about the direction of current flow. The resistance increases when the force of a magnetic field is parallel to the current flow, and decreases when the magnetic field moves at a 90-degree angle to current flow. The magnetoresistive sensor's main advantage is the ability to sense direction, and operate with a wide air gap. The sensor detects the wheel's rotational direction via magnetoresistive elements MRE, A, and B. In forward direction, magnetoresistive element, A, goes high first. In backward direction, magnetoresistive element, B, goes high first. A multipole ring can be used as an impulse wheel, while at the same time being integrated in a sealing ring of a wheel bearing. Inserted in this sealing ring are magnets with alternating pole directions. There are two types of multipole magnetic encoder, the radial type, for setting the sensor close to the radius, and the axial type, for setting the sensor close to the axle. A magnetized rotating impulse wheel mounted on the outer ring of a bearing. A seal functions both as a radial seal and an impulse wheel for the active ABS sensor. A magnetized impulse wheel integrated in the bearing seal. A layer of elastomeric material, containing magnetic particles, is applied directly on the seal flinger, which then functions as an impulse wheel. The sensor is situated on the side of the bearing, in close proximity to the seal with integrated impulse wheel. A multi-pole magnetized impulse wheel is fixed to the rotating part of the bearing, and the sensor is plugged directly into a carrier mounted onto the non-rotating part of the bearing. The carrier holds a non-detachable sensor. Its purpose is simply to attach a cable through the connector. Cap added to bearing above seal with sensor plug. Air gap size is automatically correct. ABS active sensor integrated with wheel bearing unit, for driven wheels. End cap type ABS active sensor integrated with hub unit bearing, for non-driven wheels.